We're off. So yeah, so it's cool, and y'all can mute or unmute your stuff. It doesn't matter on this one since we don't have that many people. It doesn't matter if you unmute or not. Um, all right. So taking a ride through a sound mixer. Um, so I guess familiar. I mean, how familiar are you guys? Has anybody, any of you two, uh, y'all have gone through some classes so far. So tell me a little bit about like sound knowledge that you have. I mean, have y'all been explained all of this before, or do you just
Mm.
kind of is it just kind of self learning?
Self-learning from you.
Self learning for me. Is that the same thing for you, Andy, or did
kind,
you?
kind of both. I kind of learning from you from previous experience and from the class. They kind of cover like, but even though it's analog, I mean, it's the same idea, same concept. But at HCC, since they use analog board, so everything kind of analog, but
Yeah, yeah,
the same
yeah.
idea.
Okay,
So
okay. Yeah, so like I said before, we're gonna take a ride through this mixing console, so you can see just how sound goes in and out. Mixing boards can be very, very, very complex, and but I'm gonna try to explain it in a way that makes it to where you guys can understand it. And if at any point y'all get confused, you feel free to stop me and and um, and just ask me. And I repeat myself a lot, and my family has made that very clear to me, and I am very aware of it. But when I do that, I'm just trying to make sure that you guys are actually grasping the concept, because this stuff's really important. And my goal is for you guys to be able to engineer stuff and make it sound like, I always use the phrase making it sound like a CD live. Um, and get you better at whatever your sound craft is, whether it's live sound or whether it's recording or both. Um, so here we go. So are y'all able to see the screen that I'm sharing right now?
Hmm.
Okay. So this is a it's the digital XR app. You guys might I've already used this before, but this is a good representation of a sound mixer. Most sound mixers they're all going to have the same, uh, you know, uh, parts in them. It's just how do you get to those parts in the mixer? Are those functions or things? So this is it. I kind of like the layout that the XR gives, and and right now we're talking through it, and you can see my voice is actually coming into this one that's called an ear set on here, and then this one's actually got 18 inputs on it. 16 have mic preamps, but here we go. So I always compare, uh, you know, sound. The goal is to get. You're going to have multiple instruments going out to different things. All right, and those inputs can be microphones that are for voices, or they're for drums, or they're for they could be for room mics. They could be for multiple things. They could also be um, inputs can be uh, coming from line level instruments, which would be an example. Would that be uh, maybe a computer on the stage, or an acoustic guitar, or a keyboard? But you've got all of these sounds, okay? And those are input devices, and then we need to route those to typically you're going to route those in a live sound situation to the speakers in the room so the audience can hear them. And then in addition to that, you're going to have those sounds go to monitors on stage, which could be a floor monitor speaker. It could be going to a headphone system. Um, Another output would be maybe going to a recorder. Right now, we're going to a Zoom, my computer, so you guys can hear me. Um, and so there's a lot of things that you can go out from, and then there's a lot of things that you can come in from. So I like to compare my audio. You could like we can be like riding a bus and there are roads, or you can think of it as on your house you've got a main water coming in, and then there's all these sinks in the house, and showers and stuff like that, and so that main water has a main valve on it, and then it goes to all the sinks in the house. And I think that's probably a better analogy. But we're going to ride through uh, this this mixing console, and this one's called an XR18, and I think it's going to give us a great representation on where the sound goes, and then where it comes in at, and then where it ends up. Okay, y'all have any questions on anything before I get started? All right, here we go. All right, so probably the most important, well, they're all everything everything's important, and everything affects everything, but um, in the audio industry, you hear the word preamp a lot. And a lot of hi-fi engineers, they always talk about preamp this, preamp that. Well, a mixing board wants to get the level of whatever instrument you're plugging into it to a operating level. Okay, and we call that unity on the board, and it's so the average of this level coming in needs to be around the 0. Now I know it looks like it's less here, but it's actually not, and maybe it is a little low. But I'm coming in here, and so I'm going to use this channel 16 as an example of preamp levels. But the goal is to get the average around 0 and ish. It can be a little louder than that, but then giving yourself headroom above that, to where if the person gets really loud. Um, so what the gain does, or preamp does, is it's like a main valve that you can adjust it to get the average level that I talked to up to that unity point. Okay? Does that make sense? And I know some of this stuff you guys already know, but I'm just gonna say it just so we're clear on what that's for. Now I'm gonna go into the channel settings here, and if you look on here for this channel, on this mixer, -10 at my average, or really at my peaks, it needs to be around that area. So it gives me a little bit of room above it. And this let me tell you this is the main valve here. Okay, we call it mic gain, but that mic gain, there's a few different words that mean the same thing in the audio industry. On this board, it calls it mic gain, but another word for it is preamp. Okay, which that's the first word I used. Another one could be, now we use trim also, but there's also trim here. They call it trim. So it's mic gain, preamp, trim, just the word gain. Trying to think if there's another word. I'm sure there's another word besides that, but the bottom line is this is the main, we'll call it valve, that the goal of it is to bring it up to this operating level. And on this board, it's trying to get it up to that unity level. Okay, the operating level that the board wants to, that the mixing console wants to see. Okay, now the ramifications of it being too hot is you'll get distortion. Okay, the ramifications of it being too low is you won't get enough signal. So I'm going to give you an example. So right now we're at plus 42. Okay, now just be careful. I'm gonna turn it up here so you can hear what it sounds like distorted, but just know it's going to get loud in your speakers. Okay, Y'all ready? So here we go. So here we go. Check, 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 check. Now it's probably distorting on your side a little bit. Check, 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 check. Okay. So and now I'm going to go real low. Check, 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 check. So the volume. So if you have it too low, what's going to happen is you're barely going to be able to hear me. But then if you bring the volume up later down the chain, you get my voice mixed with noise. Okay. So the goal is to bring this up on the average when I'm talking to check, 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 check around the -10 on this mixer, and that -10 is approximately the unity for this mixer. Okay. All right. Does that make sense? Okay. Now, did anybody have a question before I move on?
I have a question.
Sure.
So I guess from some other people that kind of, when I first doing sound, they kind of just tell me to for preamp kind of just get to where you kind of hit yellow, reddish, rather than you say to hit around -10, right?
Yeah, but again, don't worry about the numbers as much because different consoles are a little different.
Yeah.
Like when I first was trained on sound stuff, we didn't have all these. You had to press the PFL button, and then it routed that to a meter, and then you could look at that meter. But some you couldn't even do that. So what you did is they would just give you a red light next to the preamp, like next to this on the console itself. There'd be a little red LED. And you would sing like you were gonna sing, and you would turn it up until it distorted and the red light was blinking, and then you would turn it back a little bit. That was the poor man's way of doing it, and that was adequate. But that's how we did boards back in the analog day. Well, I know on this board that -10 on average is about where you need to be. Okay, but you got to learn your console and see where that is. But like on the X32, we've talked about it needs to be a little bit in the whatever level. I don't have it in front of me, but it needs wherever that unity point is, because you want to give yourself. Let me put it to you this way: you want to give yourself at least 10 dB of gain above, before that distortion point. At least, okay? So this isn't going to distort until it gets all the way up to here. Okay, so my average talking is flickering in the -10, but I'm still leaving myself at least 10 dB of headroom above that. Okay, you want to get it up as high as you can. So your noise floor on that channel is as low as possible. Okay. And another thing is every channel that comes into this board is going to be a different level coming in. So this level here is going to be different. But the goal is we're on every channel you have one of these mic gains. They're all going to be different. But then if you've set them all correctly, the average of every channel should look like this when you're done. Okay? Does that make sense? Did I explain that clear?
Yeah.
Okay. Perfect. So this is your first, we call it gain. Actually, what I'm doing right now is this is from beginning to end on the board. When we take a ride through this console, this is your first, we call this gain stage. Okay. You've got to get this right. This is the first thing that comes into the board. So if you adjust it here, it's going to adjust everything else down the chain. So an example of that would be the water main on your house. If I turn that down halfway, all the sinks in the house go down halfway because they're after the water main. Okay? Does that make sense? It reduces the pressure halfway. So wherever you were sending other stuff, now it's dropped too. So that's why this is really important. And I think I remember, I don't know if it was Levi or you or one of you guys were telling me at one time to mix off the preamps, or somebody had told you to mix off preamps for the house and then leave all the faders, these faders here. at Unity. Well, the reason why that's not a good idea is because, first of all, you're you're not gain staging correctly, meaning that you could get noise if this isn't set right. But then secondly, anytime you adjust this, it affects everything down the chain. You know, it affects people's monitors. So like if here's an example. If I was sending somebody a monitor mix on stage of their voice, okay? They said, I'm turning up the volume, and again, we're going to get into that section here in a little bit of where you turn up the volumes for their monitors. But say I set that, but the preamp I didn't have my preamp set high enough on here, but I turned it up to their monitor at the correct amount so they could hear themselves. Well, I come back to this and I'm like, oh, I forgot to set the preamp right on here. And then I turn it up here after I'd already given them a monitor mix. Do y'all know what would happen? You have any idea? So what would happen was, since this is the beginning of the chain, all of a sudden their monitor gets blaring to them because now I've increased it here, and I had already set their monitor to the low when this was at a lower level. Now their monitor just shot up a huge amount of volume and they're getting feedback. Does that make sense? So you've got to be careful. This is the first thing that you have to do, is you have to set the mic preamp correctly. Okay. Now, in the audio industry, we talk about also, preamps. Everybody's like, oh, preamp this, preamp that. Yes, they are very important, and the reason why people talk about them being so important is because what a mic preamp is a high gain, low noise circuit. Okay. And there's different ways to bring up the volume from a low gain to a high gain. Some things that come into the console, they're already going to be at a high level, but some things aren't. There's a lot of microphones that aren't. And so if you notice the number here, that says plus 42. Okay. So I'm having the microphone that's on this wireless microphone going into this mixer. I have to increase this 42 decibels of gain to get this up to the operating level. Okay. So that's a high gain, so that can color the sound. So the preamp circuit that we use has we'll just say it has an effect on the way that this microphone sounds. Okay, so people always talk about preamps. Sometimes people they purposely drive the preamp hard, because when the preamp distorts a little bit, they like the sound of the distortion on it. Okay, and that's okay, but generally speaking, on a sound mixer, you don't do that. Okay, but there are times to where you do it because you're wanting to get the effect of the coloration of the microphone preamp that you're using. Okay, I know that's a lot, but that's microphone preamp 101. Any other questions on that?
USB trim? What is that
Yes.
for?
So this board allows you've got two inputs per channel. You can choose the analog input that's built into it, or you can choose the USB. Okay, the USB is coming in digitally from either Pro Tools or your computer, whatever is coming from your computer typically. And this will let you bring it up or down digitally. Okay, if I choose that. See how there's this little button here that lets me choose USB. So if I flip it over to this, you lost me while I flipped it over to that. Okay.
Okay.
So each channel has two inputs, a digital input and its own built-in XLR input. And that, so one thing I didn't talk about is there's different types of connections, and we'll get into that later, but an XLR input is the same thing as a microphone cable. There's different, in the audio world, we use, different names to describe the same thing. All right. So mic cable, XLR cable, I'm trying to think of this. There's probably another name for it, but and then you have guitar cable or quarter-inch cable. That's another type. There's a few different. There's a lot of different types of connections you can do to get sound from one location to another. And you have to decide, okay, how far is the distance, and is it just one channel or is it multiple channels? I mean, and then you can talk about all the different connectors. But XLR connector is a connector, and it can be used for multiple types of signals. All right. Here we go. And so one other thing that I want to talk to you about is that's pertain to microphone gain is different microphones. Here's an example here. This is a condenser microphone. This is a dynamic microphone. This one requires power being sent to it. This one doesn't. Okay. So there's a again, I know y'all know this stuff, but I'm going to just say it again. The condenser microphone requires a voltage to be sent down the wires to the microphone. So not only are those wires giving you signal from the microphone, there's also voltage being sent down them also in the circuit to power up the microphone. Okay, so you have to decide, hey, do I have a dynamic microphone, which you don't have to have this on, or do I have a condenser microphone, and if I do, I need to turn that on. Okay. So I gotta always look at one of those texts that's spam text, somebody acting like they know me. This one was Valerie from some recruiting agency. Anyway, let's see. And then the other thing that's associated with mic gain is polarity. So do y'all have y'all ever heard of the word polarity? Do you know what that means?
I've heard of it. I don't know what it is.
Okay. What about you, Andy?
I think all I know is like phase, right? Like the sine wave.
Yeah, that's a good point. Phase is an attribute of polarity. Yeah. So when people say phase, it's out of phase. Well, phase can mean it's not exactly, because polarity is a 180-degree flip of a signal. Okay, your sine wave, your signal, and again, I don't want to go too in depth on this right now, but on a balanced connection, it has two wires that send the same signal down it, but one of them, so the wave is going up and down, up and down, up and down. Well, it sends the same signal, but it inverts the phase of one, so they're doing this down the wire, and then the balance circuit flips the phase of one side once it hits the mixing console. When they're back in phase, then you get double the signal, and but anything that was picked up on the wire gets thrown out of phase. But that's a balance circuit to reduce noise. What this is for is if you have two microphones that are further than a certain amount of, you have the same signal, you're miking the same signal, and your microphones are further than we'll just say a couple feet apart, you could have a phase problem, okay, to where it's the base of the microphone could be lacking, or it kind of gives a a chorusy effect a little bit. And I know y'all don't know what that, well, y'all know what that word means, but it gives it kind of a weird sound. And someday it would be a good, we could do an example of this, but so and it's because the sound hits the microphones at different points. So if I had a microphone here and then I had a microphone, a couple feet over here, well, my voice hits this microphone first and then hits this one almost the same amount, but just barely a little bit less. So it could cut out the bass because they're not, the diaphragms and the microphones aren't catching it at the exact same time. And so if in the effect of that is sometimes the bass is a little less on the microphone and you might get some it's hard to explain the sound. You have to hear it to understand. But you could flip the polarity on it, and then it makes the phase right if you're having that problem sometimes. Okay, that makes sense. It just takes it and does a mirror image of it to where hopefully they're back in phase if they were out of phase. And so an example of that would be if you're miking, the same instrument and, you have two microphones up and you're getting that problem, you can flip the phase button. Or if you're miking like a snare drum and you're miking the top and bottom, here's a great example. If you mic the bottom of the snare and the top of the snare with two microphones, they're facing it, but the heads are moving, you would flip the phase of one of those microphones to where they're back in phase. If you don't, you could lose bass on both microphones when you put them both together. Did I just blow y'all's mind?
I did not think about that.
Yep. Well, that's an example. Yeah. Oh, we've got at our church. When I came in, they were miking the top and the bottom of a tom, and and I don't usually do that, but it's not hurting anything. But the fact that we were doing that, I wanted to make sure one of the phase things was flipped on the bottom one, because the heads are moving in the same direction. If I don't flip the phase on one of them, you could lose some of the bass. I don't want to lose bass on a tom. That's what toms are all about. All right. Let's move on. So we've talked about preamp. And we've talked about phantom power and polarity and making the gain right. Do y'all feel pretty good about that?
Yeah.
Okay. If y'all need a break at any point, just let me know because I'll keep on going. You want me to keep on keeping on? All right. So the next thing usually in your gain section, you're going to have phantom power, polarity, and then you also have low cut. Okay, that's a filter. And a filter, there are many different types of filters, and we're going to go through, the basics of the filter today. I don't want to go in depth because we'll be here forever. I just want to get the sound through the board today. But what a low cut filter does is it does what it says it does, and there's different names for that too. A low cut filter, high pass filter are the same thing. So you think about it, low cut, okay, it cuts the lows. High pass, passes the highs, same thing. Okay. So on this microphone, it looks like it's on and it's set to 163 hertz. Okay. So if I didn't have it on, the bass of my voice would come through a lot more. Okay, so I'm going to go to a different screen here to show you. Actually, I can do it here. Y'all can hear the difference. I should turn it up a little bit in my room here too, so I can hear it. Check, 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 check. Okay, so I'm turning it up in my room here. So we got to remember 163. Okay, so I'm taking it back. You should hear a little bit more bass. Check, 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 check. Here's some bass more. And now I'm going to take out a lot of it. Check, 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 check. See how there's no bass at all? Check, 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 bass. Y'all hear that? Okay. So I'm going to go back to 163. Okay. the whole point of a low cut filter, and the reason why they give that to you is because um, on microphones, we'll use it. We'll say we'll just talk about on a vocal mic for right now. Um, Back in the day, we would have the main out of the board going to speakers, and then we would also tie those same speakers to subwoofers. Okay. Well, the human voice isn't, you can have it go into a subwoofer and it's kind of cool for a radio voice effect, but other than that, for music, it's not really a good idea to ever do that. And you can get a low rumble, and every time you hit, you wind hits the diaphragm of the microphone, it would give you a popping sound. Well, they put a low cut filter on that, and you set it. You know, a lot of boards would just have a button, and it would have this little division looking uh, symbol here, and you press it, and then it would cut off from 80 hertz on down or 100 hertz on down. And it's specifically designed for instruments that just don't need the bass. Okay. Um, and the advantage of this digital board is not only does it give you the ability to turn it on, it lets you adjust the frequency of it. So that's a pretty cool thing. Okay. So the low cut filter. Now, in mixing, we use these low cut filters and live sound for a lot of things. You know, a voice doesn't need these frequencies, you know, in this PA. So to me, that's just trash that I'm trying to get rid of. Okay, because I want to clean up my mix as much as I possibly can to where the audience hears, you know, it hears a nice clean vocal with no problems with it. So I'm going to turn on my low cut filter to everything that doesn't need it right off. So um, what do y'all think? What would be instruments that I would not put this on?
I mean, a bass guitar.
Yeah, that's right. Something you want bass on. That's a good point. What would happen if you turned it on and you put on a bass guitar?
Wouldn't hear much.
No, you try to turn up the bass and you wouldn't get anything,
Mm.
you know, because this filter was on. Yep. What would be another instrument that you wouldn't use this on?
Bass drum.
Yeah, kick drum. Yep. Andy, what do you think?
I was gonna say kick.
Oh, no, he got it too. There's
Yeah.
other instruments. Pick another one.
Uh,
What do you think?
like a low. Do you use that for low tone? Or low tone is not low enough to.
Oh, no, low tom is a great one. Yep. Yeah, so anything that you want to go through the subwoofers that you think is an instrument that goes through the subwoofers, put it on. You know, a instrument that could go either way on it would be like a keyboard. I typically like to put keyboards into the subs, so when you hit the low bass note of it, but some people will take it out, and that's not wrong. Um, but things that you would put it on that don't need bass would be vocals, violin, acoustic guitar, electric guitar, you know. So you put it on all the instruments that you don't want and then on the board you can adjust how much of the bass to take out. Okay, but some boards don't give you that ability, but this one does. Most of them today on these digital boards they do. Um, uh, but now what we're doing is we're saying, okay, we're going to take out all the trash and potential problems with feedback that we're taking it out by using this low cut / high pass filter. All right. These filters are wonderful, and you can use them for so many different things, so many and I'm just gonna just real quick, an example of a low cut filter. Yes, for vocals to take out all the trash of all the different instruments that don't need the low frequencies. But say you had you were miking a hi hat or cymbals, for instance. I don't need all that lower end frequency stuff, generally speaking, in those instruments. So I'll cut it all out of those microphones. Okay. you want to get all the trash out of the instruments with filtering that you can, in my opinion. Okay. So that's an example of a low cut filter. Okay, so all of these things here are tied to the preamp section on most boards. All right. The input gain, the phantom power, the polarity, and the low cut filter. Okay. Okay, I'm getting ready to move on to the next section. Any questions before I move on?
No.
Okay. Do you feel like you've gotten a fire hose of information, or are y'all tracking?
I think I'm tracking for the most part.
Okay. What area is a little difficult for you to?
Well, I was thinking about the low cut. I think I figured out the answer, but on a low cut, what would you do for a bass vocalist?
Oh, okay. Good point. Well, different venues, you're still going to have that on there, but for the most part, the human voice in radio. Now, that would be the exception, Zach.
Okay.
Okay. But I would still have it on there, and the low frequency on a human voice, like if for radio, is around 60 to 100 hertz. All right. So anything below 60 hertz, you should cut off anyway. But what you can do is, again, you can put it at 60 hertz still, and then you can go to your EQ and boost that low end, because the 60 hertz is the part that hits you in the chest on a kick drum anyway. Okay,
Okay.
now it's the tuning of the kick drum will determine, what tone of bass. Okay, because
Hmm.
bass is anywhere from 200 hertz all the way down to 30 something hertz, and then when below 30 something hertz, you really can't hear. You can feel it, but you really can't hear it. But you still want to take trash out, but for a vocalist, generally speaking, you're cutting it off. Is you want to cut it off as high as you possibly can, and the vocal still will sound good. Female vocals usually don't need anything less than, you can go all the way up to 200 hertz on a female vocal. You know,
Hmm.
160 hertz is probably where I would be at, but 200 hertz is fine. Um, the male vocal, maybe 130 to 160. I mean, you gotta do it per person, but you want to get it up as high as you possibly get it, and it still sound good. Okay, so
Okay.
I typically, what I do is I'll start off with it sounding thin sounding, and then I start pulling it back until the bass is where I need it to be on that vocal. Okay.
Okay.
That's a good but good question. That's a really good question. Um, I'm going to give you an example of a concert that I had. I was doing an event in Zambia for like, gosh, 15,000 people, and I'm working the stage. I was collaborating, mixing with another engineer friend of mine, and I'm on the stage, helping them all with their monitors, and I was getting this low end feedback. We had all these vocal mics going, and it was floor monitors that were facing everybody. Okay, and I was getting just this low end feedback, and I'm like, I can't get rid of it. I don't know. And, it's always hard when you get a whole bunch of microphones going at one time. And we were going from band to band, and so this band popped up there. There were no sound check or anything, and they were going. And I was getting this. It was just every once in a while I'd hear it. I'm like, I can't figure this out. I know the frequency of it, but it's just not going away. And so what I ended up doing was, I prayed, actually, because there was a whole bunch of people there. I'm like, Lord, give me wisdom on what to do here. I can't have this happen. It's feedback's distracting. And so, and then all of a sudden it popped up in my head. I put a high pass filter or low cut filter, same thing, on the whole monitor mix at 200 hertz. Okay. Now, if I listened to that speaker by itself, it would have sound very thin sounding.
Right.
Okay. but there were these huge line array speakers or big speakers to the right and left, you know, that are super loud, going out to 15,000 people, you know, and the back side of that speaker was producing low end. All right. So, and a lot of people don't think about this, but you know, when you have a speaker facing you, it sounds really clear sounding, but on the back of it, it sounds kind of muffly and so the combination of both of those together, I was treating as one speaker. The floor monitor, cutting off all the bass, and then the rumble of the back of the speakers was the lower end of my monitor. So when all that to say, when the monitor speakers had all the low end cut out of them, the artist didn't feel that way because they were hearing the back of the low end of the speaker of the big speakers. So it changed my mind shift of, oh, it's not about this speaker on the floor sounding the best it can sound. It's about all the speakers around you, you've got to treat as one speaker. Okay. So once I did that, all the feedback went away. Everybody could hear what they needed to hear. And I got a lot more volume before feedback just by using this beautiful low cut filter on the monitors. So that's kind of a tangent, but they're great. These low cut filters are a beautiful thing. And so you know, there's in recording and live sound, if it's an instrument that doesn't need those frequencies, turn the low cut filter on and set it to where it needs to be for that particular instrument and cut out all the trash. Because our goal is to cut the trash out of all the instruments, that the stuff that they don't need, to where when the instruments that do produce those frequencies that are designed for that produce it, it sounds much clearer and there's no interaction with the other with these instruments that we don't want the low end anyway. Okay, your mixes will be a lot cleaner. All right, moving on. I'm going to go into we've got a few different areas here. I'm going to briefly touch on these. How are we doing on time right now? We're at 10:49. We're almost into this. An hour now. Gosh.
I think so, yeah.
Okay. So the hardest thing, and I know I'm gonna go through the EQ section first, and then I'm gonna go into these other ones. But I'm gonna do the brief EQ. I can't go in depth because this is where you're painting the picture. All right, and this is very, very, very. It's you know, each instrument is really difficult. I mean, every how do I put it? You're painting a picture. These are your colors, and paint brushes are the type of you know, filters you're using. Or you can think of it like baking a cake or baking or cooking something. You have to add the right amount of ingredients in order for it to sound right or to taste right. This is, you got to know what filters to use, and you know, the difference between the filters and how much to add or take away on things in order to make it sound right. Okay, so when I go into this section here, I'm going to flip to a different microphone temporarily, just so y'all can hear the difference of it. All right, so I'm going to use this microphone, a dynamic microphone. So I'm going to switch around. All right. Check, 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 check. Okay, can you hear this microphone? Check, 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 check. Okay. And the other microphone, if I mute this, it goes away. Now it came back when I did that?
Mm-hmm.
Okay, good. Okay, so now we're talking on this is a dynamic microphone, so I'm going to switch over to the section here. I'm going to flatten this thing out, all right? And we're going to go through every filter on this. Here we go. And I'm going to go through this really fast. And if you guys get confused, stop me, all right? Because everything that I'm talking about is super important, and
and I want you to understand it really good. So, okay, now behind, and just also behind this, I have an RTA on it. What an RTA does, this stands for real-time analyzer. It's showing you all the different frequencies from as high as you can hear to as low as you can hear on after the changes that I'm making on the EQ. Okay. So this will give you a good visual representation. Are y'all seeing these things move quickly? Does it look good? Okay.
Yeah.
Here we go. So I'm gonna turn off the low cut first, and then I'm gonna reset everything. Check. So now it should sound more mid-rangey and more bassy. Okay. So this is the raw sound of this vocal mic. All right. I'm gonna turn the vocal down in here. It went up in volume when I did that. Okay. So here we go. The first thing I'm gonna do is I'm gonna turn back on this low cut filter. Let me find which one that is. Okay, it's this white one here. Okay, so check. I don't know if you can hear the wind hit it. Now, if I do this, watch. See how the super bass part of it went away? Okay, so I'm gonna bring it back in. So okay, now I have a radio-y type voice. Okay, so as I go down, you can start hearing the radio of my voice come back in. Check. See about 80 hertz, you're starting to hear it, aren't you? And that's what, remember you were asking about, Zach, the low end of a, if you have some type of low voice in there that's singing, anything, if you have it at 80 hertz, you're still going to get that low end of the voice. And the other thing is you can take another filter. If you really want the bass of it, you can check. You're still hearing it, Okay, but the goal is I'm turning on the low cut filter because we've already talked about this. But this is it cuts out the highs, low cut. Okay, and we're gonna set that for my voice, and I think a good check. If I had a bunch of vocal mics, I would set it higher. But for right now, I'm going to set it around, we'll just say 100 hertz, okay? Just keep it nice. There we go, 101 hertz. All right, so this is called a low cut filter, but they also have a high cut filter or a low pass filter, all right? So I'm going to go into that first because y'all already understand the low cut. So let's do the high cut filter. So now watch what happens. You're going to hear the high end of my voice go away. So check. See how it gets all muffly sounding? Check. Okay. Does that make sense to you guys? So the more I turn it to the left, the more it's going to start cutting out the highs. Check. And as I come back, the highs come back. All right. So what do you guys think it would be a good use of this? I like to keep y'all engaged.
What bass?
Great
Or,
example. Yeah.
Kick drum.
I wouldn't use it for kick drum, but you could, depending on the type of kick drum. If you're wanting like a jazz kick, you could do it. Just because something's a bass instrument doesn't mean that it doesn't have a high end to it. And I'm going to go into an EQ painting how to use EQs on another video, but at our church, we use high pass filters for multiple things. One thing I use it for regularly is if you have an instrument that has a buzz in it, and it's there's in the instrument itself is producing the buzz. You can't get rid of it, by flipping the ground switch on a direct box. And again, I know we haven't talked about direct boxes, but this is a great way to make a buzz go away. So, okay. So if you have a buzz coming from an instrument, like we'll say an electric guitar, that's a great example, or a bass guitar, you can bring this down, and then that instrument still will be able to, like if it's a bass guitar, that's not going to be a life or death um, action. It's just going to make the buzz go away. Yeah, you don't get as much high end on the bass, but most people aren't going to know. Nobody's going to notice that. Okay. So that would be an example, or an electric guitar, same thing. Electric electric guitar. You play electric guitar typically through a cabinet, or now these days they emulate cabinets and processors, but the cabinets are usually a 10-inch or a 12-inch speaker, with no tweeter on it. So naturally, that speaker has the will cut off the high end like this anyway. Okay, so just by playing the guitar through it, so you still get all the mid-range stuff, for that guitar, but this super high end, really, it's more like, I don't know, maybe about 7K on up. Naturally, it cuts off the high end on it, but anyway, I just want to bring that up. These are great filters. All right, high cut filter. Any questions on that? Does what it says it does. It cuts the highs. No questions?
I often, sometimes, I guess, more sometimes use them on overheads in the drum kit or hi-hat if it's too sharp. Is that good or bad?
That's bad.
Okay. Alright.
No, there's a better way of going about doing it, because you
Okay.
think about it, Zach. Those are the instruments that
You
should
want.
be producing the high end.
Yeah.
Okay, so what you're trying to do, and I know what your goal is. You want to have a pleasing sounding high end on those.
Right.
So what I want to get you in the mode of is listening to a sound and then say, okay, what is it about that sound that I don't like? Like, what's it doing? What's the frequency of that? Is it hurting my ears? Because a hi-hat produces frequencies all the way down to probably 200 hertz. I guarantee, like, if you were looking at it, you would see, or maybe even lower than 200 hertz. Cymbals go all the way down. Okay, so what you're wanting is a and it just be real nice and pleasing to listen to, because high end doesn't hurt your ears when it's done correctly. It's actually, it's a pleasing sound. Okay, so cymbal work, same thing. So try to listen to the attribute of the sound that you don't like. And typically the stuff that hurts your ears isn't the super high end on it. It's usually a mid-range frequency that is. And it might be a high mid-range, but still it's like it might be something like in this area right here, that's actually coming out a lot, that's hurting your ears. And then you just you could cut that if you wanted to. But I would want to hear the sound, and then maybe what you do is, because typically I don't have to do this to a hi-hat, or I don't have to do this to a cymbal. Usually on a cymbal, what I have to do is I do this, and then sometimes I even do, I'll go this. I know we haven't talked about this yet, but we're going to check. I'll do this to it, and then, but I'll end up putting a compressor on it, and again, we're going to get into compressors. But what a compressor does is, when something is hit really hard, it turns down the volume of it, and as soon as it gets softer, it releases the volume back to where it was. So because it takes the transient spikes in volume and reduces them to where you can, when somebody hits the hi-hat really hard, it doesn't pop out of the speakers. So compressors give you freedom of equalization. Okay, and if you notice, the order that this console put these in is they put the EQ before the compressor. So any EQ changes you make get compressed. Okay, this will make more sense once we talk about the compressor, but that's really important. The order that you put things in is important. Not as much on the gate. It is important on the gate, but it's very important from an EQ and compressor perspective. Okay, all right. That kind of answer your question?
Yeah, I always assume that I should use a compressor. I just don't know how to use them, so I would just use an EQ
Well,
instead.
good. Well, that's why you're on this video right now, because you're learning and, you know, moderating and helping with all the details on this thing to help other people be able to understand this stuff also. This stuff is really, 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 it's taken me years. You know, I'm what, 52 now? I'm old as dirt. And, you know, just about every situation that you come across, I probably experienced in here, and it's taken me so long to understand it. I remember when I was in audio school, sitting in the back, we had this big, it was an MCI, they called it an inline console, and gosh, it was huge, and the routing on it, I remember the teacher talking to me about it. I'm like, I'm never going to understand this stuff. It's too complicated. And I did. I mean, over the years, it took me years to really get a grasp on it. But once you get the grasp of it, you know, it's you start understanding. Oh, okay. Well, this is why, you know, they call DCAs because they're trying to emulate, you know, a VCA, which is voltage control amplifier, on these old analog boards. That's how they had to do it. And, you know, in the digital world, they call it digital control amplifier. You know, but there's all this stuff that they do to emulate what the older boards did, and you understand, you know, okay, this is where we started at, you know, back in the day, and this is what they're doing now, you know, and they're trying to, you know, but you know, my point to all that is don't. We're going to go through a lot of concepts, and don't get discouraged because there's a fire hose of information here, and hopefully you guys will be able to go back and just watch these videos. And you know, right now my goal on this video is just to get you to understand the different filters. And by the way, all of these things, you know, are called filters. In audio, we have different types of filters, and the first one I showed you was the you know, the low cut or, you know, high pass filter, and then the invert of that, high cut, low pass filter. You know, the other thing we didn't talk about is on a high cut filter, the other reason why you would use this is you would put this on a subwoofer to take out all the high end to where the subwoofer gets just bass. Okay. Yeah, I can go all the way down to here. I would put that on the output that goes to a subwoofer, to where that subwoofer doesn't get all that higher end because it doesn't need it. Just kind of like what we were doing on any instrument. We want to cut out the trash that we don't want in there. Same thing on a subwoofer. We want the subwoofer to get the frequencies that it's designed to have. Okay, so these high pass and low pass filters are, you know, pick whatever terminology you want to call them, but you know, they're beautiful filters. And this board, there's other attributes to these high cut low pass filters to where you can say, I'm going to make this shelf more steep to where when you put it at 95 hertz, it's cutting off everything below 95 hertz completely. Here, it's saying, okay, I'm going to start at 95, and then as I get further away, I'm going to drop it. You know, if I'm at, let's say, 75 hertz, I've only dropped it, you know, 10 dB by then, and then the further you get away, the more it drops it. That's called the slope of the filter, and that applies also to the high cut filter. Also, they'll have attributes about it. This particular filter doesn't give you that ability, but that's called they call it the pull of the filter is what they call it. And again, that's just an attribute of filters, but there's just the steepness of the filter. Okay. Hopefully I didn't blow your mind on that one. Okay, y'all want me to move on to the next one? Okay. So we've talked about high cut, low pass filters. Let's move on to the next one here. Let's talk about shelving filter. This is an easy one. And this, you can have a high frequency shelving filter and a low frequency shelving filter. They just go in the opposite directions, okay? So I'm going to give you an example what it is. You set it to a frequency, and then you can turn up, check, 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 or turn down of that. And what a shelving filter does is exactly what it says it's going to do. It's everything above that frequency, above 5K, 5,000 hertz, it's turning up the same amount, generally speaking, okay? There'll be a little bit of a slope at the beginning, but then it shelves it up. Okay. And it'll go up like that, turn all those frequencies up, or it'll do the same thing, turning all those frequencies down. Okay. That makes sense? And we can do that on the low. So I can say at 120 hertz, I'm going to turn everything above, check, 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 above, at 124 hertz and down, up, or I can do the same thing. And okay. That's a beautiful filter, isn't it? Zach, you love that. You want to marry it, don't you? Wait, you are married. That was a dumb joke. But anyway, so that's what a shelving filter does. Any questions on the shelving filters?
What would you primarily use it on?
Oh gosh, lots of things. Overheads. Or hi-hat. If I want to get a little more sizzle on a hi-hat, I can use that to do that. What's another example I would use a shelving filter? Sometimes on vocals, the filters, I can get high end on a vocal with different filters. A shelving filter is a great one to do it on. A peak filter or a parametric EQ, you can do it also, but they have different sounds to them. So you decide, you know what, I think on this person's vocal, I want to use a shelving filter on it. And because I like the tone of the shelving filter on it for the high end. A shelving filter is a dramatic filter. Like you'll hear a lot of change on it. I mean, parametric's the same. It just depends on the attributes that you've assigned to it. But I mean, you want to hear a lot of high end on the vocal. This is a great way to do it. Or if you want to take a high end off of it. On my ear set, I use a shelving filter. If you notice on the ear set channel, I've used a shelving filter on it because I need to cut some of the highs out because these little microphones are super crispy. So it's a great tool to use to be able to do that, to take in high end out really fast and efficiently. Everything above 5K, I've reduced 13 dB. And that's just what this microphone needs for it to sound normal. Okay. Why they make them that way, I don't know, but they do. So, okay, so that is shelving filter. High frequency shelving filter, low frequency shelving filter, high cut filter, low cut filter. Those are what we've learned so far. Any other questions on that, or you want me to move on? All right, we're moving on. Here we go. Okay, so the next one, the most popular filter of all, the one that is extremely difficult to understand, but we're going to make it through, and y'all will, at the end of this, you will understand. It's called a peak EQ, or another word for that is parametric equalizer, okay? I am going to show you on this pink, well, it doesn't matter. I'll show you on this high one. That's fine. Okay, so you can turn up, check, check, or turn down, check, check, of the frequency that you choose. Okay? Y'all understand that? Now, when I turn it up, there's a peak to it. Check, check, check. See, that's the middle peak. So the center frequency is 5.57 thousand cycles per second. Okay? Or frequency, or hertz. I'm sorry, not cycles per second. Well, I guess that would actually be the correct thing. But I'm turning 5,000 hertz essentially up 8 dB with the slope or the bandwidth at a 2.0 bandwidth. That's how wide or narrow this is. Okay, so I'm going to make it really narrow. I guess I could do let's see. There's 3.9. I wonder how high I can go with it. Yeah, okay, so this is a narrow. Check, check, check. So it's going to affect just that frequency a lot. So if I want to do just that frequency only, I would have a narrow bandwidth, okay? Now, if I want a wider bandwidth, I make it, let's just say I'll do 0.5. See how it made it really wide? So it's going to be more of a dramatic filter because it's going to affect the frequencies around it more, okay? Check, 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 check. Check, 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 check. Okay. Any questions up? So turn up or turn down of the frequency that you choose. So if you were wanting just to notch out one frequency only, what would you do? This is y'all's little quiz.
Just make it super thin and then
Okay.
pull it down.
Yeah, and you know, when you have tablets and stuff, you can put 2 fingers on the tablets and then open it and close it. Here, it's kind of a pain because I have to.
Well,
I
you
have to
can,
type
I
in and-
think the quality, I don't know if you can adjust the little bars where it says gain, frequency, and quality. I don't know if you can drag it.
You know, you're probably right. Yep. See, I didn't know that. That's something you just taught me something that I did not know. Okay, so okay. So you can just slide it that way. So check. Okay, good. I never knew that. That's the first time I saw that. And that's awesome.
That makes
check,
it
check.
easier.
Yeah. Oh yeah. Okay. Check. So see how narrow I can get that? It'll go to 10. So that's really narrow. Check. It sounds like an instrument, like a it sounds like a filter on a guitar, like if you wanted to have like a cool effect. And by the way, that's when on guitar pedals, when they add those funky effects, they're controlling filters and they're using oscillators to move the frequency back and forth. That's tons of, but they use combinations of different things to create different effects. So, I typically like a 1 is a good check. The filter is dramatic enough and musical enough at 1 to do most of what you need to do. But if you need it more dramatic, like if you're trying to take a frequency out of there that's driving you nuts, check. You'll have more of a dramatic filter. So like this one here is set to 2. So check. Say I want it to be a tighter, or I want it to be. Is that not? I'm doing the wrong one, aren't I? Why isn't it messing with that? Oh, I have to click on that. That's why. Am I not like on the right thing here? Let's say, it's because I'm set to shelving. I forgot to change that back to peak. Okay, so now if I do this, see it's it's like on a narrow filter, but if I want it to be wider, check. So now if I'm like, say I want to take the mud out of the person's voice, I would do that. Check. Find the mud frequency you don't like, and then check. Okay. All right. I know that was a lot, but the peak filter. So I'm going to repeat it one more time. I know I repeat myself. Everybody knows it. Turn up or turn down of the frequency that you choose. Okay. And then the bandwidth, they call it quality on here. I don't know why they call it on quality, but whatever. Check. Narrow bandwidth, wide bandwidth. Okay. The correct terminology is bandwidth. Check. So now I took the mud out of it. Now, like say on this one, say I want to find the frequency I hear, a mid-range frequency I hate. Check. Right there is what I don't like. So I'm going to cut that. Check. Now it sounds more normal. Check. And I think I want to make the bandwidth a little bit wider. Check. Now I'm going to add some high end to my vocal. Let's find the frequency I like. Check. So now I've made it clear sounding without hurting your ears. Check. And then if I decided, hey, you know what? I want to add more bass to my voice. I mean, you can make this lower or higher. Check. And then if you have another filter available, like I've got this one here, I've used the wrong one for low mid, but it doesn't matter. You can use any of these filters anywhere. But say I wanted more low end on my voice. Check. So there's lots of things you can do. Okay. Peak filters are beautiful. They're great filters. Okay. They're very useful. And I highly recommend them. All right. Y'all got to see me EQ a vocal pretty quick. Check. I still hear a little bit of upper mids in here. I'm going to make a feedback again. Check. So you turn up at the frequency you don't like. and then nuke it. Check, 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 check. So now the vocal sounds more normal. This is where you're training your ear to hear the frequencies you don't like. Okay, like this one here that's that mid one. I hear a mid one here. Check, 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 check. I hear that right there. Check, 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 check. Now it sounds more normal to me, at least through my Genelec monitors here. All right. Anything else? Check, check, check. I still hear a little bit of mud too. Check, 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 check. Check, 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 check. There we go. Check, check, check. All right. All right, there's your EQ 101. These other filters on here are just different. They're like the VEQ is a different type of just parametric EQ. It just has a different flavor to it, but again, same things on it. Yeah, that's all they give you. So those are the main ones that you'll have on every mixing console. Okay. Any burning questions that you have to that you'll want to know on EQ stuff before I move on? I know you'll have to have this is the main thing. This is your spices that you add to your hamburger to make, or your cake to make it taste good. This is the hardest part about engineering, is knowing what to do here. Okay.
I think I'll probably have more questions on it once we get to actually putting instruments in.
Yep.
So,
well, and I'll say this real quick, just so you don't get overwhelmed. Y'all don't get overwhelmed by it. You see all these different, little level meters on here, on the RTA. What I do on every instrument, I divide it up 4 ways. Okay, the super highs, or we'll call it highs, high mids, low mids, and lows. Okay, and for different instruments, that area is a different frequency, but you slice it up to 4 sections. Okay, and then just learn what those sections are, because like a kick drum, for instance, what I do is I'm like, okay, on a kick drum, there's attributes of a kick drum that I want to emphasize, and there's attributes of a kick drum that I'm trying to put a hole in it also, and then I've got the bass that hits you in the chest. Okay, those are the things that I'm thinking about on a kick drum. Okay, well, I know the bass part, is going to be around the 60 cycles, 60 hertz area, 60, 70 hertz area. But aside from that, I want to put a little hole in it, and I want it to sound a little hollow. Well, I know that's in this, 200, 300 area. So I'm gonna put a hole in it. And then now we're talking about tick. I want a snap on it. Okay, well, that tick on a kick drum, it depends on the type of music you want. If you can have a low tick, or you could have a super high tick in the heavy metal. It doesn't, depending on what type of music you have, you can decide what the coloration of the tick. But for a kick drum, those are the things that you're listening for. And I know that was just 3 things, but for most instruments, that 3 things is enough. But you can divide it up into 4. Or a vocal, you need to divide up into 4 areas. You want the breathiness, the super high end, and then the mid range of it, and then the mud of it, and then the lows on it. That's what I'm thinking in my head. And every instrument, like I said before, I know I'm repeating myself, but I want to hammer this home to you guys that you've got to divide it up, and you, in different instruments, have a different area. And on a great way to find the frequencies that you don't like, you're listening for, okay, what is that mid-range frequency that's driving me nuts? Well, this microphone kind of stinks, and it's got this super upper end area that's driving me nuts, and this is 3K. And like Zach, like when you're talking about cymbal work, the part that hurts your ears, it could be anywhere from here. You've got to define, like, where is it hurting my ears? Because most likely, if it's hurting your ears, it's probably a mid-range frequency on that cymbal. And again, you can EQ it out, and that's fine. But but what my point is, that the compressor could fix your problem too, and you could have a problem with something else too that's causing that problem. But on this microphone, I turn up the frequency, I find the one that I'm not liking, and then I cut it. Check, 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 check. Boom, the problem solved. Now that filter just made this microphone sound beautiful. Okay. All right. Moving on. Going to compressors. Are y'all ready? All right, we're going to dive into compressors. Okay. How are you doing on time, too? We're 11:22. Gosh, this is just, I could talk about this stuff for forever, and I know that this gets, it's a fire hose. If I need to shut it off at any point, y'all just need to say, hey, Willie, that's enough for today, because my brain is like, is going to explode. Okay, so compressors are, this is difficult, and y'all are just going to have to hang with me here. Okay, so what a compressor does is when you, I'm going to, at its basic form, and I'm going to use a vocal for an example. When you sing really loud, it turns down the volume. And then when you talk soft or sing soft, it brings the volume back up. It releases the volume back. Therefore, what's happening is it's squishing your dynamic range of the super loudest and super softest and squishing it to allow you to bring that vocal on top of the mix to where you don't have to keep moving the fader up and down, and you're able to hear all the different words that I'm saying. When I talk real soft, you can hear me talk soft. If I talk loud, it's bringing it down, but still your volume it stays consistent. If I didn't have the compressor on this, that would have blown your speakers out, you know? So that's the goal of the compressor. Now, the threshold on here is when does it start compressing, okay? The gain reduction is when it starts, you know, how much is it turning when this red thing goes down, that's it turning down the volume of my voice, okay? When it's going back up, it's making my voice go back up in volume, okay? The ratio is like, how much is it turning it down once the vocal volume goes above this minus 30, okay? That I have the threshold set at, okay? Mix, don't worry about that. Mix it's blending the original to the affected sound. That needs to be at 100%. They give you mix on here. I don't know why, but they do. Gain is now that you've caused when I'm talking or singing, the volume to go down, you need to make up that gain. Okay. So when I'm talking real loud, you know, it's averaging, in my opinion, around 7, but this is to make up what you've lost here. Okay. So if I didn't do that, let me give you an example. Check, check, check. Okay, so I'm not compressing at all right now. So my vocal is at this volume. Now I'm going to start bringing it down more. Now, oh, look, my vocal has gone down a lot. You can barely hear it. Now I got to make that up. Check, 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 check. Now I've made that gain back up. But now my soft stuff is brought up and my loud stuff is brought down. Check, check, check. Check, 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 check. The goal is to get it even. Now I can put the vocal on top of the mix and let the compressor do the work. And you hear... You're hearing all the soft stuff I do and the loud stuff I do. It doesn't pop out of the speakers. Okay. The attack is how quickly is it going to turn down the volume once the volume goes above the threshold. The hold is how long is it? Well, actually, before I go into hold, let's go to release. Release, once the volume goes back below the threshold, how quickly does it release the volume back up? The hold is how long is it going to wait before it goes to the release? Okay, so it's going to so if I have an infinite hold, it's going to hold it and then start the release. Okay? So again, attack is once the volume goes above the threshold, how fast is it going to bring the volume down? The release is once the volume goes back below the threshold, how quickly is it going to let the volume go back up? And then the hold is how long am I going to hold it before I allow the volume to go to the release milliseconds that you chose? Okay. Does that any questions on that?
What does the mix? Is it
The mix blends the original with the affected.
just
Does
like
that make
when you
sense?
have reverb and delay, kind of like the
Well, no, it's
Rhythm.
on this. Well, it's on this channel only. So that they give you a mix one. So right now at 100%, you're getting the full affected signal. When I start bringing this down, it's going to mix my original vocal before it was compressed or anything with the compressed vocal. Okay. I mean, there's reasons why you do that, but most of the time I wouldn't. I personally don't need it, but sometimes, like if you're wanting to get some of the transient to come back in a little bit, you could do that, I guess.
Oh, that,
You know, it
that
just
that's
will
what I
blend
was
the.
gonna ask you.
Yeah, I guess while you're learning compressors, leave it at 100%. You know, and then if you want to play with that to get some of the original sound before the compression added to the compressed vocal or whatever instrument you have, then you can start releasing, you know, bringing it to whatever percentage sounds good to you. Okay. So for you, Zach, um, did you have any questions on this, or do you? Because I know you missed a couple of these things. Threshold. I'm gonna go through it one more time, really, for everybody. Threshold is the point in which the compression starts. Okay. The ratio, and I don't think we talked about this before, is like once the volume goes above the threshold, how many dB, like for every dB you go above this, how many dB am I going to turn it down for every dB that it goes above it? Okay, so essentially the higher the ratio, the more dramatic it's going to be. Okay, again, mix on here is blending the original unaffected compressed with the compressed vocal. Leave that at 100% because I want to hear what the compressor's doing at 100%. The gain is after you compress it, making that gain back up. Zach, were you here to hear that when I did that example? Okay, so I'm gonna bring this down again. I'm gonna do the example one more time because this is important. So right now you're hearing my unaffected. This isn't compressed at all, so you just don't see anything, and I'm not making any gain back up. Okay, so now I'm gonna compress it. Okay, so you're gonna start hearing my vocal go down in volume. Check, 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 check. So now my vocal's down in volume, but it's compressed. Now I'm going to make that gain back up. Check, 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 check. You bring it back up to where it was. So now I'm not really concerned about what this number is. I just want to make up the gain that I lost. Okay. So now I've got a compressed voice that the gain has been brought back up. So now if I talk real loud, check, 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 it doesn't blast out of your speakers. But when I talk real soft, you can hear it just as good. Okay. All right. And then the attack is once the volume goes above this threshold, how quickly is it going to start compressing? Turn the volume down. That's what the attack does. Okay. The release is once the volume goes back below the threshold, how quickly is it going to let this go back up? So a long release, when I stop talking, now you can watch this here go slow. I'm going to do it, make it go real slow. Check. See how slow it goes? It still hasn't fully released it. Okay, if I make it go fast, watch. Check. See how quickly it comes back? Check, check, check. Check, 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 check. It's almost instant. Okay. If I just do a medium slow, check, 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 check. This is just like it's like it's a more smoother, check, check, check. Okay. That makes sense? Okay. And the hold is how long is it going to hold before it goes to the release? Okay. Like you can say, I want it to hold for 500 milliseconds before I even allow it to go into its, how slow it's going to release. Okay. Any questions?
You may have said it, but what is it releasing?
It's releasing when you see this volume gain reduction happen here. Okay. So it's saying like once the volume goes below the threshold here, how quickly is it going to let it go back to not compressing? Okay, so watch this, because as this red line goes back up to the top, it's like turning the volume back up. When it's going down, it's turning the volume down. Okay, that's why it says gain reduction. Okay, so if I have it as a real slow, watch, check. Now see it's taking a while for it to come back up to normal. See, check.
Oh, so it takes longer
the
to
fader
adjust the volume?
Yes, just the
Okay.
volume back up to where it was. Now if I do it
Okay.
real fast, watch, check. It's like an instant. Like it'll turn my voice down still, but as soon as my volume goes back below the threshold, it immediately comes back up. Okay.
Okay.
I choose for more of a smoother release.
Yeah.
Check. So it's still fast, but it's not super fast. It's more smooth. Check. Does that make sense?
I think so.
Okay. Are you getting hung up at all, Andy, on any of this? Compressors are pretty hard, and it's something you should play with to really understand them. But watching the video and then listening back, say, okay, Willie said, that the release did this. Let me try it. That's why it's good that you're able to see the effects of it. As I do this. Okay, now this gets a little complicated here, so hang with me. All right. There's a thing called a filter. Okay. What the filter does is it takes my vocal, and if I turn this on, all right, it will compress off whatever filter setting I have set here. Okay. And then it'll pass the full signal through, the unfiltered sound through, but it'll be triggering off of the filtered sound. All right. Did I confuse you guys at all?
So it's a filter on top of so you have the EQ as the filter, and then it's a filter on top of that for the compressor.
Yeah. So this compressor has a filter built in to that instead of the full signal going into this threshold, it's going to send just this filtered sound into the threshold. So the compressor triggers off the filtered sound. Okay. But the compressor is passing the full range sound through it, but it's being triggered off the filtered sound. Okay.
Okay.
You want me to give you an example why you would use that?
Well,
Or why
I
don't
mean,
I ask you what do you think would be an example of that?
I don't know, because the church that I'm at right now, the way that they EQ, they have a flat EQ, but they EQ within the compressor
On
on all the. It's really weird, and
okay, yeah. So I don't understand. I don't understand how. I mean, any filter that's in a compressor is for the to key the compressor off a filter.
Okay.
But it's not designed to go to the house. This is designed to go to the compressor only to trigger how it compresses. But what goes in and out of the compressor is the full range signal. You know what I mean? With the compressed sound that is being triggered from the filter. So an example of this, here's a great example. You're going to see another example when we go to the gate area, but would be say a de-esser. Like say somebody had a lot of sibilants happening. Okay, say I just want to get rid of the sibilants. Well, I know S and T's happen anywhere from, like, we'll just say from 2K up to 8K. 6K is probably the area that it's mostly in. So what you would do, here's a great example of a de-esser. You have a super fast attack, super fast release, all right? But I'll only want to get my the S's and T's, okay? So what I do is I put the filter on, put it around, we'll just put it around 6K is great. So it's and I'm going to tell it, and the filter is saying, I am putting if you notice, it's kind of like a peak filter that's boosted, that's cutting everything else around it except for 6,000 hertz in that area. See that? See, if I sweep it down, it goes low, high. All right, but my sound of my voice hasn't changed. It's the what's going into the threshold is this. Okay, now watch what happens. It's not going to compress at all or barely. It's only get my S's and T's. Watch. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See how it's triggering off my S's and T's? Check 1, 2. I can probably even give myself a lisp. Check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. See how I've created my own de-esser. So now I can go into my EQ and make it real bright sounding. Check, 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 check. You know, it's super bright, but you don't get the S's and T's like you normally would. Check, check, check. Now I've de-essed my vocal. It doesn't hurt your ears. If I didn't have the de-esser on there, it would kill your ears. But I made my own de-esser with a compressor. Pretty cool, huh? All right, but I'm taking that off there. Almost there. Check, 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 check. Let me make up the gain. Check, 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 check. Okay. I bet that was pretty interesting, wasn't it? I remember when I was back in school that I had to manually make my own de-esser by using what they called the key input, and that key input is what this is right here. Or side chain key input, same thing. Or key input. This is just this side chain gives you a filter built in. That's kind of cool to be able to do that. All right.
I have a question. Do you ever have a need to do more than one, like a sidechain filter in one channel?
Yes, but not on the same compressor. It would be on a different processor.
So how would you have to set two different?
Yeah,
different
so like
compressors
for
do
instance,
that?
like well, I mean, you could. I mean, usually you don't need a side chain for two different attributes of an instrument, but you get a side chain built into a compressor if you decide you want to use it. But also on your gate, you have a side chain filter also. Okay. So and we're getting ready to go in the gate area, but an example would be like when I'm EQing well, toms are a great example on drums. You know, I want to, when on a tom, again, we're going back into the EQ stuff here, but you've got the attack of the tom, the tick of the tom, you've got the bass of the tom, and then you've got you want to put a hole in the tom just like a kick drum because they're very similar to a kick drum on the equalization on them. But the problem is if I turn up the highs on the tom to give them the tick that they need to make them sound awesome, if I don't turn that drum off when that drum's not being played, it makes the kit sound overly bright. Okay, so I have to put a gate on it. But the problem is, and we haven't talked about gates, but you'll understand this once we go into the gate section here in a moment. If that tom, there's a cymbal right next to that tom. So what I don't want is when he whacks that cymbal for the microphone that's on the tom to open up. Okay. So what I do is I put a key input filter or a sidechain filter on the tom, and I put it at the resonating frequency of the tom, okay, which could be like a low frequency. Let's just say it's 200 hertz or 160 hertz or whatever the loudest frequency is on that particular drum. And then when he hits that cymbal, well, the cymbal's frequencies, yeah, it gets super loud, but they're at a different frequency area, really loud. So if I'm telling the key input of that gate to only open up that tom on that low frequency, he could whack on that, that cymbal all day, but that gate's not going to open. But when he hits that tom, the resonant frequency of that tom opens the gate quickly. Okay, that's a great example of a side chain key input filter. That's really going to help you a lot, and it'll make your drums sound great. Okay. All right. Are you all ready to move on to the gate? It's 11:41 right now. We're almost out of time. So let's get to the gate, and then I know this turned into taking a ride through the console to talking about the different filters, but this is good stuff. Y'all are hanging in there with me. This is and this is stuff you need to know, it's just super, all this stuff is super important, but understanding all these different tools will help you be able to make your mix really good. All right. Noise gate 101. It is what it says. It takes away noise, unwanted sound. When a gate is like a compressor, except for it works in kind of the inverted way. So what a compressor does is when you go above the threshold, it turns down the volume. Okay. A noise gate, when the volume goes below the threshold, it turns down the volume. Okay? I'm going to repeat that so other people that might be listening to this understand. A compressor, when the volume on the threshold goes above the threshold, the compressor turns down the volume at all the other settings that we talked about. A gate is the opposite of that. When the volume goes below the threshold, the gate turns down the volume. Okay? And so, and you can use these. I use gates on just about almost everything I possibly can. There's things that you don't use gates on, but for the most part, I would say 80% of the things I do, I have a gate on it. Okay, so what the advantage of a gate is when that instrument's not playing, it's essentially turned off. It's like the fader's turned down. But the gates are so fast; they're faster than any human could ever turn up the volume. It instantly turns it on. It does it to the settings that you said. You can set it to where it turns it on slowly, but generally speaking, it can turn it on super fast. Okay, so let's go through the things. So you got the threshold here on a gate. When the volume goes below the threshold, that's when it starts turning the volume down. See it go down when I stop talking? All right. Now, the range is how much volume is it going to turn it down once I go below the threshold. Okay. So right now it's going to turn it down 60 dB. I'm going to stop talking. All right. So you saw it turn it all the way down to 60 dB. If I went to, let's say, 20 dB, it'll only turn it down to 20. See that? Okay. And that's fine too. This isn't, you want to, sometimes you don't want to turn it down so much. Well, we can leave it at 60 though. That's fine. All right. The attack, hold, and release are the same thing as it is on the compressor. How quickly does it turn down the volume when you go below the threshold? Okay. So if you have it set really, I'm sorry, that was my bad. I said that wrong. When the volume goes below the threshold, when the volume comes back up above the threshold, how quickly is it going to open back up? Okay, that's your attack. So if I have a slow attack, watch what happens. Check, check, check. It takes a second for it to open up. Check, check, check. So you see how it's slow? It goes slower as it opens up once I go above the threshold. Check, 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 check. You can see it. Now if I go real fast, watch. Check. It opens up instantly. Y'all see the difference on that? Okay. The hold is how long is it going to hold before it goes into the release, just like on the compressor. Okay. And then the release is how fast is it going to turn off once the volume goes back below the threshold. Okay. So I'm going to go real fast one time. Check. Yeah. See, as I talk, it's turning it down super fast. It almost cut me out. Okay. Check, 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 check. All right. Check, check, check. But if I have a slow release on it, check, 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 check. See how that's working? So the attack is how fast is it going to, once you go above the threshold, how fast is it going to open back up? The release is once the volume goes back below the threshold, how quickly is it going to turn the volume down? Okay. So I would recommend, like on a vocal, I don't want it turning off too quickly. Okay. The hold is how long is it going to hold once the person stops talking before it goes into the release. Okay. Any questions on that? I know this stuff can get confusing. You might have to watch this video like 10 times. And, you know, I just have to say, I sometimes mess up what I say. So I might mess up a word here or there, but you'll get the gist of it if you watch the video. All right. So let's move on. Now, we talked about filter before. Now, this is where your key input filter is really important. If you can turn on the filter and then you can turn it to the frequency you want. If this was like a tom or a kick drum, I would make it really low. So anything that's in this area, like cymbal work, would never make this gate open up. Okay. My voice still has, you know, frequencies in that area, but you know, if I go down really low, it might be like if I make this tight, you'll never see how it's not even opening up. Check, 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 check. See how it doesn't open up once I get to frequencies that my voice doesn't produce. Check, 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 check. See how that works? So you could make it real tight and put it on the resonant frequency of that drum, and then other frequencies around it, you know, cymbals and all this other stuff won't ever open it. Okay. All right. And that's how you turn it off and on. And I have to say this too. See how it says self on here? You can have the gate open and close off another channel's instrument. Okay, I don't mean to blow y'all's mind, but you can. So, like for instance, like if you had a bass guitar and you want the bass guitar to open up off the kick drum, you can do that. Or I don't know if you, or maybe it would be the reverse of that. But my point is that there are times where you might do that to make things line up better. You know, maybe you'd have the kick drum open up off the bass guitar player, but I don't know. Some people do stuff like that. I don't, but I have done it off of. I've used other instruments to key off other things for different purposes. Okay.
Would you ever do it like
It would be more on a compressor. I think I would do what I just said with a, you know, a kick drum and compressor or bass guitar. I might do it on the compressor side, not the gate side. But go ahead.
would you ever have it open up, like, I guess, let's say a snare open up the rest of the drum kit, or a different part of the drum kit open the rest of the drum kit?
Let me think about that. I put a gate on the snare for effects purposes because I want the snare drum to only go like if I wanted a specific reverb to be on the snare drum, I'll make sure I have a gate on that snare to where the rest of the kit isn't, the mics of the rest of the kit aren't like if I didn't have a gate on that snare mic is still picking up the rest of the kit. You know, so when you hit a cymbal, that it would get that reverb on it. But if I have a gate on the snare, then that reverb never sees the rest of the kit. It only sees the snare. So if you're talking about key input, the snare to open up other parts of the kit, no, I wouldn't do that. But this you can get creative once you understand the key input, because the key input can help you in a lot of ways. An example here's a great example that I've done before. I've had guitars, the electric guitars. I want my electric guitars to be on top of the mix, but I don't want my electric guitars to bury my lead vocals. Okay, so you could have your electric guitar key off the lead vocal mic, all right, and have the compressor compress just a couple dB, not a lot, just a little bit, okay, to where when the lead vocalist sings, it brings the lead electric guitars down only 3 dB or for whatever you decide. And then as soon as that person stops singing, then the guitars come back up on top of the mix, giving the impression that the guitars are always on top of the mix. Okay. But then when the person sings, they're on top of the guitars. You know what I mean? That would be an example of using a key input filter or a side chain to work for you. Okay. And to help you. Okay. The other thing I want to talk about on gates, I know that that's like super high level audio engineering, but I just want to share that with you. I mean, these are some of the things you can do. I don't recommend doing that at the beginning. You don't need to do that. It's fine to never do that, but that is something that advanced engineering you can do. One thing that I do live with gates that helps me in a huge way is I'll put gates on vocal mics live. When I first started engineering, I didn't do that. Now I do it. And the reason for it is when a person's not singing in the microphone, it's turning that microphone off. And that prevents a lot of feedback. But you make it to where when the person gets up and talks in the mic, that it opens immediately. So the person never notices it. But what the advantage of it would be like if I had 10 vocal mics and then one person's talking, you set the gates up, the threshold up high enough on all the other vocal mics, just high enough to where the ambient sound of that other person talking through the speakers in the room, you set the threshold high enough to where it's still turning all the other vocal mics off. The gates are. But the threshold's down low enough to where when that person talks in the mic, it immediately opens up that microphone, so which prevents so much feedback. So essentially what's happening is when a microphone's not being used, when somebody's talking in between songs, those microphones are turned off. You're not having to think about that. And then as soon as somebody walks up to that microphone, it turns on instantly, which prevents feedback. Okay. All right, well, moving on. Okay, right now we're at 11:55. We got 5 minutes left. Okay, and I'm gonna buzz through this last thing here. And again, we're probably gonna have to have another video here. But vocals, we've talked about compressors, gates, EQs, input. Sends are, once you've processed the vocal, you can send it out to monitors. The sends area is the area where you can send it. Think of it like another faucet in the house. Okay. We're probably gonna have to have another video on just routing, but that's what you use. You can use sends to go to a monitor on a stage, a headphone monitor, a subwoofer. That's a great one. You can instead of having your subwoofers come off the main mix, you can have them come off a auxiliary send. And then you can choose what you want to go to the subwoofers. Because I don't need vocal mics to go to subwoofers. I don't want those subwoofers to see vocal mics, generally speaking. So I would have it come off a monitor send or an auxiliary send, and then the subwoofers only see what I want, and then I can choose how much I want to send on that particular channel. Okay, but then the channel goes from there, from the sends area, and you can. And different boards have different amounts of sends on here. And then from here, this is your main area. So, you have that area where it's sending out to different things, but then you can also keep going down, and then you can have it go to the left and right, which goes out to your speakers in the room. You can panorama. It means pan, and what pan means in the audio world is just put it to the right speaker or to the left speaker. I don't know if y'all heard that or not, but in my room it moved back and forth. But no, you probably wouldn't have heard it. If I did it here, you might. Let's see. No, I don't know if you did or not. Did y'all hear it go from speaker to speaker?
I didn't.
Okay. Anyway, it's if I did this, well, anyway, pan just means make it go from speaker to speaker. Let's see, and then this turns it off, going to the main speakers and onto the main speakers, assigning it to that, and then over here is your main fader that goes out, so you can turn it up and down to your house speakers, and then you can adjust the EQ to your house speakers, and then we've already talked about the compressors, EQs, and all that. Okay. So that's how you get in and out of a mixer. All right. Well, we made it through the mixer today. We're about out of time. That was 2 hours long. Did y'all have any questions any burning questions you wanted to ask me? I know that was a lot of information, and hopefully it was enough to where it gets you guys thinking about what I want to do is I want to show y'all how to paint pictures with equalization. That's the part that sets engineers apart, So, but all these things are really important, But EQ, if I had to place if I only had one thing to have to make my mix sound good, the filters are the most important, by far, most important out of everything. These other tools are very important, but not nearly as important as that is. Okay. So if I had one thing, it would be EQ. All right. Well, this concludes going through the Mixer 101, and we'll do this again. And I think Zach will be able to post this video and edit it a little bit.
Yeah.
But we're gonna try to do this frequently for you guys. And this was our first one we did. So, our goal is to help you guys be able to create awesome mixes live and help you all to really understand how to what you're talking about. And I have one other funny story. I had a friend, a great musician, phenomenal musician that knew a little bit about engineering, but just phenomenal musician, and he'd been in tons of studios over the years. And he was on stage, and he would make up frequencies that wouldn't even apply to what the human ear could hear. But he would tell the engineer that from the stage, and act like he knew what he was talking about. Like, can you turn up that 100,000 megahertz frequency a little bit just to make it sound a little more, and obviously your ears can't even hear up that high, just to see how the engineers would respond to him. And he'd tell me that live, and I'm like, you're crazy. And but he was joking. But anyway, thank you guys for tuning in today, and we'll keep you guys posted on the next class we do. Y'all have a wonderful week.